Welcome everybody. Happy New Year 2021. Let's know some surveying important questions. 1. What is the triangulation? Triangulation is a method used to determine the location of a fixed point based on the laws of trigonometry. These laws state that if one side and two angles of a triangle are known, the other two sides and angle of that triangle can be calculated. 2. What is the framework? Every survey, from mapping a continent to a small plot of land, depends upon a carefully measured framework, which is thereafter treated as free from error. Subsequently, the details are filled in the framework by less elaborate methods. 3. What is the horizontal control? The fixation of a framework for a survey is known as horizontal control. It can in general be established either by traversing or triangulation or by a combination of both. Some of the other methods to provide horizontal control are trilateration and electromagnetic distance measurement (EDM) traversing. 4. What is the EDM in surveying? Electronic distance measurement. EDM is a method of determining the length between 2 points using electromagnetic waves. 5. What is meant by traverse surveying? Traverse is a method in the field of surveying to establish control networks. It is also used in geodesy. Traverse networks involve placing survey stations along a line or path of travel, and then using the previously surveyed points as a base for observing the next point. 6. When we use triangulation, triangulation is most suited for hilly areas, whereas traversing is suitable for flat areas. Triangulation is preferred for hills and undulating areas, since it is easy to establish stations at reasonable distances apart, with intervisibility. In plain and crowded areas, it is not suitable as the intervisibility of stations is affected. 7. What is the main steps of triangulation? The field work of a triangulation is carried out in the following well-defined operations. 1. Reconnaissance. 2. Station preparation. 3. Baseline measurement. 4. Measurement of angles. 8. What is the geodetic control network? Terrestrial control points. A geodetic control network. Also geodetic network. Reference network. Control point network, or control network, is a network often of triangles, which are measured precisely by techniques of terrestrial surveying, or by satellite geodesy. 9. What are the types of geodetic control networks? 1. Horizontal control points. Points known of X and Y. Triangulation. 2. Vertical control points. Points known of Z only. Benchmarks. Leveling. 3. Three dimensions networks. Points known of X, Y, Z. GPS networks. 4. Geodynamic networks. Points known of X, Y, Z, T. 4 dimensions points, where T is the time at which take X, Y, Z. 10. What is the object of station marks, signals and towers? The object of station marks, signals, or towers is to provide a surface mark with a permanent mark buried below, and a good target on which to observe, accurately centered over it. It should also include a complete description to enable the station to be recovered even after many years. 11. What are the 3 segments of GPS? 1. The space segment, which includes the constellation of GPS satellites, which transmit the signals to the user. 2. The control segment, which is responsible for the monitoring and operation of the space segment. 3. The user segment, which includes user hardware and processing software for positioning, navigation, and timing applications. 12. What is the main functionality of GPS module? Calculate location coordinates, latitude, longitude. Calculate altitude, above mean sea level. Calculate direction heading, direction of the movement, For example, SW, SE, NW, NE. Speed calculation. Based on changing the location coordinate over a period of time unit. Optionally calculate distance between two measurement points. Dilution of precision, DOP, measured as horizontal, vertical, positional, 3D, and time dilution of precision. A DOP value between 2 to 5 is considered as good enough for the route navigation, whereas the DOP value above 10 are considered poor and should be rejected. 13. What is the GPS accuracy and limitations? Common factors affecting the accuracy of GPS. GPS technique employed, for example, autonomous, WAD GPS, DGPS, RTK. Surrounding conditions, satellite visibility and multipath. Number of satellites in view. Satellite geometry, HDOP, GDOP, PDOP. Distance from reference receivers, non-autonomous GPS. For example, WAD GPS, DGPS, RTK. Ionospheric conditions. Quality of GPS receiver. The precision or accuracy quoted by many GPS manufacturers is often done using a statistic known as CEP, circular error probable, and are usually tested under ideal conditions. CEP is the radius of the circle that will contain approximately 50% of the horizontal position measurements, reported by the GPS receiver. This also means that 50% of the positions reported by your GPS will be outside of this circle. Due to this variation in the CEP and horizontal position calculations, the distances measured, using the location coordinates returned by the GPS unit, may not be accurate and vary. 14. What is the minimum specifications to check in the technical document provided with the GPS tracking unit? 1. Calculation of location coordinates with CEP less than 5 meters, more the value less the accuracy. 2. Support for remote configuration OTA, SMS, needed to troubleshoot, or control aided features. 3. Power supply 9 volts 24 volts. Higher the range better, are the chances that the unit won't fail due to intermittent high voltages. 4. Operation temperature range 10 degrees 70 degrees. 5. GPRS Class B and Class 12. 6. Internal battery backup of up to 4 to 6 hours. 7. Support GSM frequency band 900 and 1800 MHz. 15. Why the surveying is the basic important work to civil engineers. To fix the national and state boundaries. To chart coastlines, navigable streams and lakes. To establish control points. To execute hydrographic and oceanographic charting and mapping. To prepare topographic map of land surface of the Earth. 16. What are the parts of total station? Look to the picture. 17. How to leveling the total station. Leveling the total station must be accomplished to sufficient accuracy. Otherwise the instrument will not report results. Leveling the instrument takes 30 to 45 minutes. Make sure you can see all targets from the instrument station before going through the process. Step 1. Tripod setup. Tripod legs should be equally spaced. Tripod head should be approximately level. Head should be directly over survey point. Step 2. Mount instrument on tripod. Place instrument on tripod. Secure with centering screw while bracing the instrument with the other hand. Insert battery in instrument before leveling. Step 3. Focus on survey point. Focus the optical plummet on the survey point. Step 4. Leveling the instrument. Adjust the leveling foot screws to center the survey point in the optical plummet reticle. Center the bubble in the circular level by adjusting the tripod legs. Step 4. Leveling. Loosen the horizontal clamp and turn instrument until plate level is parallel to two of the leveling foot screws. Center the bubble using the leveling screws. The bubble moves toward the screw that is turned clockwise. Rotate the instrument 90 degrees. And level using the third leveling screw. Step 4. Leveling. Observe the survey point in the optical plummet, and center the point by loosening the centering screw, and sliding the entire instrument. After retightening the centering screw, check to make sure the plate level bubble is level in several directions. Step 5. Electronically verify leveling. Turn on the instrument. By pressing and holding the on button, you should hear an audible beep. The opening screen will be the MES screen. Select the tilt function. Adjust the foot level screws to exactly center the electronic bubble. Rotate the instrument 90 degrees and repeat. Step 5. Adjust image and reticle focus. Release the horizontal and vertical clamps. And point telescope to a featureless light background. Adjust the reticle crosshair focus adjustment until reticle image is sharply focused. Point telescope to target and adjust the focus ring until target is focused. Move your head from side to 0 side to test for image shift, parallax. Repeat the reticle focus step if parallax is significant. Note: when the instrument operator changes, the reticle focus may need to be adjusted. 18. What is the least count of surveying equipment? Theodolite. Least count is 20 seconds. Prismatic compass. Least count is 30 minutes. Least count of leveling staff is 5 mm. Dumpy level. Least count 5 mm. As it is based on staff reading thats, while least count is 5 mm. Total station. Least count for total station for angle is 1 second and distance is 1 mm. 19. What is closing error in a traverse? Due to errors in the field measurements of angles and distances, the traverse, if plotted according to the field measurements, will not close on the starting point. The distance by which the end point of a survey fails to meet with the starting one is called the closing error, or error of closure. 20. What is the contour line? In cartography, a contour line, often just called a contour, joins points of equal elevation, height, above a given level, such as mean sea level. A contour map is a map illustrated with contour lines, for example a topographic map, which thus shows valleys and hills, and the steepness or gentleness of slopes.